This time we're going to discuss three-dimensional array and its addressing function. For three-dimensional array, there are three indices involved now. I is the index for row, j the index for the column, and k the thickness index. So look at our example here. We declared a three-dimensional array with the name num, and this is a 3D array of integers. The first size here is the value for the rows, so this tells how many rows are there, and the second is the number of columns, and the third is the thickness. So we could denote this as our index I, which is the row index, and this is j, the column index, and k, the thickness index. We can represent this as a 3D object having two rows. Okay, so this is the first row. Again, by default, remember that array indices starts with 0. For I, it's 0 to 1, okay, because that is 2. And for j, this is 0 up to 2. And for k, it's 0 to 1. So the values of I are 0 and 1. For j, it is 0, 1, and 2. For k, it is 0 and 1. So there are two values since we have 2 here. And there are 3 values since we have 3 here. And we have 2 values since we have 2 here. And so, in our 3D object representation of the 3D array num, the first row, which is denoted as I equal to 0, is this part here. That's the first row. If we're going to slice this, so there are now 2, right? You have 2 parts. This one and another one is this. Okay. So this is your I equal to 0 and this is your I equal to 1. Below here is your I equal to 1. This is I equal to 0. So the I equal to 1 or the second row is this part here below, which is this one here. For the columns, there are 3, which are j equal to 0, 1, and 2. So this one here is our j equal to 0, the first column. This is the j equal to 1, the second column. And this is j equal to 2, the third column. So again, the first column is this one, j is equal to 0. The second column is j equal to 1, which is the middle column, this part here. And the third column is this part here. For the thickness, there are 2, k equal to 0 and k equal to 1. So this part here is your k equal to 0, the first thickness, and this part here is k equal to 1. So the first, which is k equal to 0, is this part here, which is the front slice. So this is the k equal to 0, and this is the k equal to 1. This is the front slice, and this is the back slice. Now, how many ways can we combine without repetition the 3 indices, I, j, k? We call that permutation, right? In mathematics. Permutation is how many times you can combine n objects are at a time without repetition. So it would be I, j, k, the first. The second would be I, k, j. The third could be j, I, k. And the fourth would be j, k, I. The fifth is Kij. The sixth is Kji. So there are 6 ways. So remember, in mathematics permutation, the formula is simply n factorial over n minus r factorial. N is the number of items. In our case, there are 3 ijk, and R is how many of the items at a time are you going to combine? Also 3. So you'll have 3 factorial over 3 minus 3 factorial. So that is simply 3 times 2 times 1 divided by 0 factorial, which is equal to 1. And so we have 6. So there are 6 ways to combine without repetition, without duplicates, the 3 indices ijk. And so it is possible that there will be 6 ways of ordering the elements of a 3D array in the RAM or in the main memory. But there are only 2 commonly used ways, and that would be the row major order and the column major, okay, which we have discussed last time for 2D array. So although there are 6 ways to order the 3D array elements in the RAM, there are only 2 ways that most computer or memory manufacturers are using: the row major and the column major. And as I mentioned last time, Intel-based computers or the Intel processor use the row major memory architecture. Now, which of these 6 possible ways is the row major and which is the column major? The row major is the row-wise, right? Meaning our primary consideration is the row, and then followed by the column, and then followed by the thickness, in that order, in that priority. So this is the row major. Row major is IJK order, and we also call this the row-wise order. For the column major, obviously, it would start with J, right? So it would be JIK, not JKI. JIK order or column major order. This is the column-wise order. Now, we will discuss only these 2 ways, the row major and the column major. How do you arrange 3D array elements in row major order? So let's list this time the elements of the given 3D array in row major order. So this is row-wise. So our first consideration is the row, followed by the column, and then the thickness. So first, we get one row, this one here. You slice that, and this becomes this. This is your I equal to 0, and the bottom is your I equal to 1. After we have listed all the elements in the first row, then we move to list all the elements in the second row. After considering one row, next we consider is the column. So we move from the first to the last column. And then for the first column, we list all those elements there. So this would be in one column, okay, which is this one, the first column. We have 0, 0, 0, and this is the indices here are 0 for I, j is 0, and this is 1. This is 0, 0, 1. So this will now be num 0, 0, and then next is num 0, 0, 1. This is the j equal to 0. After the first column, we move to the next column. So the next column now for the first row is the center. And then we list all the elements there. starting from k equal to 0 and then 1. So this would be num 0, 1, this one here, 0, 1, 0. So this is 0, 1, 0. This is 0, 1, 1. So the next would be 0, 1, 1. So these two elements are the elements on the second column. That is when j is equal to 1. Next, we consider the third column, and the first element here in the third column has indices 0 to 0 and 0 to 1. So in the list, we have num 0 to 0, and this is num 0 to 1. And again, these two elements are the elements of the third column, that is when j is equal to 2. We are now done with the first row. This time, we will move to the second row, which is this one here. And in the second row, we first consider the first column, which is this part here. And there are two elements in the first column. The first element has indices. I here is 1, so this is 1. And the j here is 0. And the k is 0. So next would be num 1, 0, 0. Next, at the back of this is 1, 0, 1. So next element in the order is num 1, 0, 1. Okay, these are the two elements on the first column of the second row. So this part here is when your I is 0, or the first row. And this one here, these two here, are the two elements of the first column of the second row. Next to consider is the middle column. And the first element here has indices 1, this is 1, 1, 0, and this is 1, 1, 1, right? So in the list, we have 1, 1, 0, and the back element is 1, 1, 1. So these are the two elements at the second column of the second row. The first element on the third column of the second row has indices 1 for I, and for j it is 2, and for k it is 0. And at the back it is 1, 2, 1. Okay, so we list them here. Num 1, 2, 0, and num 1, 2, 1. So these two again are the elements of the third column with index 2 on the second row with index I equal to 1. So the first 6 elements here are those on the first row, and for each row we list them column by column. So the first column, second column, third column, and going to the second row we list them again by column. This is the first column, second column, and third column of the second row. So this is how they are arranged in the RAM. The first element is at position or location 1, and the second is 2, this is 3, 4, 5, 6 in the structure, 7, this is 8, 9, this is 10, 11, and 12. So there are 12 elements. Why 12 elements? Because you have 2 rows times 3 columns times the thickness is 2. So that gives you, this is 6 times 2, you have 12 elements. That's the total elements. And notice here in the row major order that since it is row-wise and the first half is the first row, then all the first indices here are all zeros. This is 0, 0, 0, all are zeros. And for the first column, the column index is 0, the same. For the second column, it is 1, the column index. And for the third column, the index is 2. For the second half, which are the elements of the second row, the first index is 1, which indicates that it is on the second row. And the first 2 here on the second row is at column 1. So the column index is 0. And the next 2 here are those at the second column with index 1. So these 2 are 1. And the next 2 here are the elements on the third column with index 2. So that's why this is 2. So that is the order of the elements as stored inside the RAM for row major order or for Intel-based memory architecture. Now look at the addressing function for row major. So we now have here 3 indices. Say this is locate num I, j, k. We start with L sub O just like in 1D and 2D. L sub O, which is set to 1, plus for row-wise or row major, our primary reference is the row. So that is why that is I, the row index, because this is row major. And then we subtract the base of I. So again, since we have 3 indices, I, j, k, the base value of I is denoted as B1 and the upper is U1. And the base for J is B2, the upper value for J is U2, and the base for K, the thickness index, is B3, and the upper value is U3. So in the formula, we have I minus the base of I, which is B1, times this expression here is equal to the number of elements in one row. One row because this is row major, or our primary reference is the row. If we're going to look at the 3D object here, representation, the number of elements in one row, say this one here, that is one row. How many elements are there? 1, 2, 3, 4, 5, 6, right? As you can see here in our list, each row has 6 elements. This is first row and this second row. So 6 elements. The value of this is 6. But how do we get 6? It would be 3 times 2, right? 1, 2, 3, 3 columns times 1, 2 thickness. 2 thickness. So that is 6 elements, right? That is 1, 2, 3 times 1, 2. 3 times 2. This is 3 elements here and 2 elements there. That is one row. Now, how do we get the number of columns and the number of thickness? The number of columns is simply this one, right? U2 minus B2 plus 1. That is the number of columns. times the number of thickness, or the thickness is K, right? K is in terms of B3 and U3. So this would be U3 minus B3 plus 1. Quantity, this quantity times this quantity, which is, this quantity is number of columns, and this quantity is number of thickness, or the thickness. That is why this is U2 minus B2 plus 1 times the quantity U3 minus B3 plus 1. Again, this one is number of columns, while this one is number of thickness. Multiply these two, number of columns and number of thickness, that gives you the number of elements in one row. Plus, the next consideration after the row is the column. That's why this is J, minus the base value of J times this expression here is the number of elements in the intersection, take note, intersection of one row and one column. Number of elements in the intersection of one row and one column. So number of elements in the intersection, intersect one row and one column. This is one row and this is one column. Where do they intersect? Their intersection is this one, right? That's the intersection. How many elements are there in the intersection? There are two, right? This is the first element and the second element in the intersection of one row and one column. So the answer here for this given example is 2. But what is 2? In general, what does it represent? It simply represents the thickness, right? This is thickness 1 and thickness 2. Okay? That's why the expression we have here is U3 minus B3 plus 1, because it is the one that gives us the number of thickness. So again, this part here is number of elements in the intersection of one row and one column. After considering the row first and then second the column, the third consideration is the thickness. So that's why we have here K minus the base of K, which is B3. For this part here, again, what is this? It's the number of elements in one row, because that is row, the primary consideration. And how do you get the number of elements in one row? It is the number of columns times number of thickness. And then this one is column J minus the base of J times this part here is simply the number of elements in the intersection of one row and one column. The intersection is this part here, which is the thickness, which is 2. And the thickness is given by the expression U3 minus B3 plus 1. And after this one here, the last consideration, thickness K minus B3, what we multiply here is just 1, because 1 is the number of elements in the intersection of one row, intersecting one column, intersecting one thickness. So you intersect one row, this one, with one column, with one thickness, which is this, for example. So the intersection of one row and one column and one thickness. So the intersection of these three, one row, one column, one thickness, is this one element here. That is why the value here is times 1. 1 is the intersection of one row, one column, and one thickness. Having understood already the meaning of the addressing function for row major order, let's now try to apply this addressing function by locating any one of the element here in the list. So let's verify, say this one here, the element, if it is indeed at position 6 using our addressing function. So let's locate the element num 0, 2, 1. Using the formula, we have L sub O is 1 plus our I here is 0, our J is 2, our K is 1. So I is 0 minus the base 0 times the number of elements in one row, again, is how many? It is 6. Okay. This one is 6. This is number of columns is 3. And number of thickness is 2. 3 times 2 is 6. Plus J is equal to 2 minus the base times the number of elements in the intersection of one row and one column is found to be equal to 2, right? Times 2 plus our K is 1 minus the base times one element. So this is now equal to 1 plus, that is cancelled out, 0. That would be 2 times 2, that's 4. And then plus 1, this is 1 times 1 is 1. So 4, 5, 6, the answer is 6. So our addressing function formula returns to us that the address or the location of this element or the position of this element in the array structure is at the 6th position, which is consistent with our list. Now let's move to column major or the JIK order or the column-wise order. In column major, our primary reference is the column. So that's why this is J. That's the column index. And then we multiply it with this expression here is the number of elements in one column. Okay, because our primary reference now is column. How do we get the number of elements in one column? In one column, if we're going to take one column, say this column, how many elements are there? There are 1, 2, 3, 4, right? 4. And how did we get 4? By simply multiplying the number of rows and the number of thickness. So number of rows is given by that, okay, U1 minus B1 plus 1, that is the number of rows, and multiply it with the number of thickness, okay? So that's why this is U3 minus B3 plus 1. Again, U1 minus B1 plus 1 is the number of rows, and U3 minus B3 plus 1 is the number of thickness. So the number of rows, which is this one and this, that's 1, 2, that's row 1 and row 2, number of rows, given by U1 minus B1 plus 1. And the number of thickness is given by this one and that, so that is U3 minus B3 plus 1. Again, that is the number of elements in one column. After the column as our primary reference, next or the secondary reference is the row. So this is now I minus B1, the base value of the row index. And this is the number of elements in the intersection of one column and one row. So intersect one column and one row. So one column, say that is the yellow highlight, that's one column. And then say this one. So they intersect, the row and the column intersect at this point, right? And how many elements are there covered by the intersection? There are two. This and this. There are two elements. And this two is simply the number of thickness. The number of elements in the intersection of one column and one row is given by the expression U3 minus B3 plus 1, which is simply the number of thickness. And then plus the next and the third consideration is the thickness, so K minus the base of K, which is B3 times 1. And what is this one? 1 is the number of elements in the intersection of one column and one row and one thickness, which is the same as what we have in here a while ago, right? It's equal to 1. Let's review. Let's compare these two addressing functions of row major and column major. This is number of elements in one row because that is our primary reference, the row. This is number of elements in one column because this is our primary reference, is column. And the next consideration is J for row major, while in the column major it is I. And so this is simply the number of elements in the intersection of one row intersect with one column. Okay, so this one is number of elements of one column only, while this one is number of elements in the intersection of one row and one column, while this one is number of elements in the intersection of one row intersect with one column intersect with one thickness, which is equal to 1. While in the column major formula, this is J, so column index, so this is number of elements in one column. And since that is I, row index, this is simply number of elements in the intersection of one column and one row, because the order here is column, row, thickness. And this is the intersection of one column, one row, and one thickness, which is the same as that, equal to 1. Okay? So I hope the two addressing function formulas are clear to you. Okay, let's try now to list all the elements in the column major order, just like what we did here. For column major, you get one column and list all the elements per row, because this is J first and then followed by I. So get one column, this is the first, and then list all the elements per row. So first row is this one. First element and then second element. And then this is the third, and then at the back of this, that's the fourth. Okay? So this is now num 0, 0, 0, the first one. The second is num, the index I is 0, and J is 0, and the thickness is 1. So this is the two elements in I equals 0, the first row of column 1. The third element now is num row I equal to 1. So this is 1. And j is 0. And the thickness is 0. And the fourth one, which is at the back of number 3, is num I is 1. The column is 0. And the thickness is 1. So this is the two elements on the second row of the first column. So this is when I is equal to 1. After that, we have listed all the elements in the first column. So these 4 elements here are the elements at the first column, that is j equal to 0. We move to the next column or the center column. So next consideration is this one. In the second column or in the middle column, this would now be your number 5, number 6, number 7, and the back of number 7 is number 8. So the fifth element on the second column is num I here is 0, and the j is 1, and the k is 0. Next is the one labeled number 6 at the back of number 5. That is num 0, and j is 1, and k is 1. So these two are the elements on the first row of the second column. Number 7 is num I here is 1, j is 1, and the thickness k is 0. And at the back of number 7, that's number 8, the indices are 1 for I, for j it is 1, and the thickness is 1. So these two elements are the elements at the second row on the second column. Now that we are done with the middle column or the second column, okay, so these are the 4 elements of the second column, which is j equal to 1. Let's move now to the third and the last column, which is this one here. So this is our number 9, number 10, number 11, and the last number 12. Number 9 now, what are the indices? Num 9 is at the row I is equal to 0. The j is 2, and the thickness is 0. Number 10 is num row is 0, column is 2, and the thickness is 1. These two are the elements on the first row of the third column. And number 11 is num I is 1, column is 2, and the thickness is 0. And the number 12 is num 1, 2, 1. Okay? So these two elements are the elements at the second row or I equal to 1. And all of these 4 elements here, 1, 2, 3, 4, are those 4 elements on the third column where j is equal to 2. For the column major order list of elements in the RAM, this is position or location 1, this is position or location 2, this is 3, 4, 5, 6, 7, 8, 9, this is the 10th, and this is 11, and this is 12. Notice that the order of the elements for this 3D array, for some machines that use row major order, it is this one, 1, 2, 12. So that's the first up to the 12. For some machines or computers that use the column major memory architecture, it is this order. Now let's try to find, using the addressing function for column major, the same element that we locate for row major, which is this element located at the sixth position of row major order. So that's num021. Num021 in the column major order is this one, the 10th element, num021, right? It is at position 10 in here in column major order. So let's check if we can have a consistent value using the formula of column major order. So this time, let's locate num 0, 2, 1. And in the formula, that's L sub O. So it's 1 plus, our I is 0, J is 2, K is 1. So this is J 2 minus 0 times, that is U1 minus B1 plus 1, the number of rows, and this is U3 minus B3 plus 1, the number of thickness. So that would simply be 4 plus, that is I minus B1, I is 0 minus 0 times the number of thickness, that's 2, plus K is 1 minus 0 times 1. So we now have 1 plus 2, that is simply 2 times 4, that is 8, plus, that is cancelled out, 0. This is 1 times 1, that's 1. So the result now is 8, 9, 10. Okay, so we have a consistent result. So the position in our list is 10, and what we got using the addressing function formula for column major is also 10.